सो आज हम आपके लिए लेकर आए हैं थर्मोडायनेमिक्स। थर्मोडायनेमिक्स द मेजर टॉपिक्स इन एवरी एग्ज़ाम। ओके, बेसिकली पीजीटी केमिस्ट्री के लिए ये बहुत ही इम्पॉर्टेंट टॉपिक्स है। इसमें 2 या 3 क्वेश्चन हर बार आता है। ओके, सो जो लोग WB मद्रासा पीजीटी एग्ज़ाम दे रहे हो और जो लोग झारखंड SSC दे रहे हो पीजीटी के लिए, सो उसके लिए थर्मोडायनेमिक्स बहुत ही इम्पॉर्टेंट है। ओके, सो हम पहले बोल देते हैं कि ये इसमें जो इंक्लूडेड टॉपिक्स हैं वो मैंने 2 टाइप्स में डिवाइड कर दिए हैं। तो देखो, पहले है लॉ ऑफ थर्मोडायनेमिक्स, हीट, वर्क एंड एनर्जी, स्टेट फंक्शन दैट इज़ इंटरनल एनर्जी, enthalpy, entropy and gives free energy and their significance criteria for chemical equilibrium and spontaneity of reaction. Okay, and next variation of free energy with temperature, pressure and volume, gives Helmholtz equation, entropy changes in gases for reversible and irreversible process, Hess law, bond energy. Okay, the state function are very important for this chapter. Okay, our first law of thermodynamics is the equation, and here entropy changes in gases for reversible and irreversible process. These 3 topics are very important. From these topics the questions are very often asked. Okay, so if the video is helpful for you, then please do like the video, and अगर आपको ये इस टाइप का वीडियो और भी देखना है तो प्लीज़ चैनल को सब्सक्राइब ज़रूर कर दीजिएगा। सो पहले हम ये लेक्चर नंबर 1 है, तो पहले हम कॉन्सेप्ट को क्लियर कर लेते हैं चैप्टर का, देन हम क्वेश्चन प्रैक्टिस करेंगे। ओके, सो फर्स्ट इन थर्मोडायनेमिक्स द बेसिक कॉन्सेप्ट आर द सिस्टम, सराउंडिंग्स एंड यूनिवर्स। ओके, सो व्हाट इज सिस्टम? सिस्टम इज द पार्ट ऑफ यूनिवर्स विच इज अंडर ऑब्जर्वेशन। ओके, इफ वी टेक ए cup of tea, then tea is the observation. Okay, and the surroundings is the part of universe under that system. Okay, so universe is a system plus surroundings, that is universe. Okay, and what is boundary? Boundary, the surface separating system and surrounding is called boundary. Okay, so basically system को 3 types में divide करते, open system, closed system and isolated system. Okay, for open system, that is you can take an example, that is tea in a cup. Okay, here exchange of heat and matter both take place. Okay, in closed system, that is exchange only energy, not matter. Okay, so you can take an example, hot water in a closed vessel. Okay, next isolated system. In isolated system, you can take an example, thermoflux. Okay, so here energy and matter, neither energy nor matter. Okay, both are not exchangeable. Okay, next we can study state function and path function. What are the state function? What are the path function? Okay, state function is the property of a system that depends on state, that is initial and final state of the system. Okay, the examples are, that is temperature, pressure, volume, internal energy, gives free energy, entropy, enthalpy, that's all. Path function depends only path of the system. Okay, that is heat and in work. Okay, basically state functions are symbolized by capital letters and path functions are small letters, that is heat q, small q, and work, that is small w. Okay, next extensive property and intensive property. Okay, from this the questions are asked. So extensive property, that depends on amount of substance. Okay, example, mole, volume, internal energy, gives free energy, entropy, enthalpy, that's all. Okay, mass. Intensive property does not depends on amount of the substance, that is temperature, pressure, molarity, molar volume, vapor pressure, melting point, boiling point, surface tension, viscosity, density, specific heat capacity, refractive index, etc. They are additive in nature. This question is very often asked. Okay, so intensive properties are additive in nature. Next, process. In thermodynamics there are very such process that are isothermal process, isochoric process, exothermic process, endothermic process, isobaric process, adiabatic process, cyclic process. Okay, so this is the basically these are terms. Okay, so first isothermal process. In isothermal process, that is temperature constant. Okay, so delta T is equal to 0. Next, if we consider exothermic process, that is at constant temperature, delta H, that is enthalpy of the system, is negative. Okay. Next, endothermic process. At constant temperature, delta H is positive, that is endothermic process. Isochoric process, at constant volume, that is isochoric process, delta V is equal to 0. In isobaric process, P is equal to constant, that is pressure constant, so delta P is equal to 0. For adiabatic process, Q is equal to 0. Okay, here delta Q not is equal to 0, only Q is equal to 0, that because Q is a path function. Okay, cyclic process, delta U is equal to 0, that is internal energy, delta E or delta U. Next, heat and work. What is work? So at first we have to relate P, that is pressure is equal to force by area. So force is equal to pressure into area. W, we know that work is equal to force into displacement. Okay, so if we put the value of force, that is P external into A, displacement, that is L. Okay, so minus P external into A into L. Okay, area into length is equal to volume, so minus P external into del V. Okay, so W is equal to minus P external into delta V. Here negative sign is there because here that's indicate the volume is decreased, or you can see that force and displacement, they are in opposite direction. Okay, so the negative sign is here, consider here. Next, expansion. Okay, for expansion of gases, that is volume is equal to V final minus V initial, that is delta V is equal to positive. Okay, if you consider that a vessel, that is okay. Next, okay, expansion, for if you consider that is V initial. Okay, or here you can conclude that this V initial and this is V final. Okay, if volume is increased, okay, internal pressure, if you external pressure is put and volume is increased, then delta V is equal to positive. Okay, delta V is equal to positive, that is delta V final is greater than V initial. So W is equal to minus P external into del V, as delta V positive and P external always positive, so positive into positive and the negative sign is formed up there, so W is equal to negative. Hence work done by the system is always negative. For expansion, work done by system is always negative. If the system is work, then W is equal to negative. Okay, next, compression. For compression, delta V is equal to delta F minus delta I, that is negative. If here for compression, delta V final is less than V initial. Okay, so delta V is equal to negative, W is equal to minus P into delta V. P external is equal to positive, as delta V is equal to negative, so negative into negative, that is positive, W is equal to positive. So work done on the system is always positive. Okay, if system is work, then W is equal to negative. If surroundings is work, then W is equal to positive. Okay, for free expansion, P external is equal to 0. So we know that W is equal to minus P delta V, so W is equal to 0, as P external is equal to 0. For free expansion, that is work is equal to 0. In isochoric process, V is equal to constant, so delta V is equal to 0. Hence W is equal to minus P delta V, so W is equal to 0. Okay, next topic is heat. These are the very important concept, so please practice this. Okay, heat flow from high temperature to low temperature. This is the properties of heat, and heat is in a path function. Okay, the units of heat are joule, kg, joule, calorie. Okay, from this heat, okay, the unit changes are, these are very important for this, from this chapter. Okay, the numerical, for this numerical problem, 1 liter atmosphere is equal to 101.3 joule, 1 calorie is equal to 4.2 joule, 1 joule is equal to 10 to the power 7 arc, and 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. These are very important for numerical problem. Okay, unit conversion. Next, internal energy, that is E or U. Okay, you can denote internal energy E or U, or E, sorry, E or E. Okay, some books denoted E, some books denoted E. Internal energy is the sum of the all energies, that is kinetic energy, potential energy, rotational, translational, vibrational. Okay, all type of energies, sum over is the internal energy. Okay, so for this case, these two things are very important. For isothermal process, temperature is equal to constant and delta E is equal to 0, that is internal energy 0, and for cyclic system delta E is equal to 0. Okay, first law of thermodynamics. First law of thermodynamics is delta E, that is internal energy, is equal to Q plus W, that is heat plus work. Okay, so basically for this first law of thermodynamics, there are many types of concept are there. For ideal gas, if we consider isothermal process, for isothermal process temperature is equal to constant, delta T is equal to 0, so delta E is equal to 0. We know that here we can consider for isothermal process T is equal to 0, delta E is equal to 0. Okay, so put these values are. Next, for first law of thermodynamics, we know that delta E is equal to Q plus W, so put the value delta is equal to 0, hence Q plus W is equal to 0. So there are both two cases. If Q is equal to minus W and W is equal to minus Q. If Q is equal to minus W, that is in isothermal heat absorbed by system is equal to work done by system. Okay, minus that means work done by system. Next, in isothermal, work done on system is equal to heat released by the system. Okay, next, these are the very important concept. Next, cyclic process. For cyclic process, delta E is equal to 0. Here we can write this. Okay, so delta E is equal to Q plus W from first law of thermodynamics, so Q plus W is equal to 0. Hence here both cases are there, that is Q is equal to minus W and Q is equal to W is equal to minus Q. This both cases are there also takes place. In isochoric process, V is equal to constant, that is delta V is equal to 0, so W is equal to minus P external into delta V. Delta V, if we put the value 0, then W is equal to 0. Okay, so work is equal to 0. Now delta E is equal to Q plus W, so here W is equal to 0, so delta E is equal to QV. QV is the heat at constant volume. Okay, so here two cases are there, Q is equal to positive and Q is equal to negative. If Q is equal to positive, then internal energy always positive. Okay, so if temperature increases, internal energy also increases. Next, if we consider Q is equal to negative, so in this case delta E is equal to negative. So if temperature increases, internal energy decreases. Okay, next, for adiabatic process, Q is equal to 0. Okay, so delta E is equal to Q plus W, hence delta E is equal to W, Q, as Q is equal to 0. So here two cases are there, W is equal to positive or W is equal to negative. At first, work done on system increases the internal energy if temperature is increased, and W is equal to negative, work done by the system decreases if internal energy work done by the system decreases internal energy if temperature decreases. Okay. Next, isobaric process. P is equal to constant. So delta P is equal to 0. Now delta E is equal to Q plus W. Hence delta E is equal to QP minus P delta V. If we put the value W is equal to minus P dV. Okay. Now delta E is equal to delta H minus P dV. As there we can write, that is delta E is equal to QV. Okay. And now delta QP is equal to heat at constant pressure, that is enthalpy. Okay. So if we rearrange this, delta H is equal to delta E plus P delta V. This is a very important formula for numerical problem. Now P from ideal gas equation, PV is equal to nRT. So this will be put from this, and delta H is equal to delta E plus delta Ng RT. This equation also very important for numerical problem. Okay, where delta Ng is equal to summation over number of moles of gaseous of product minus summation of number of moles of gaseous molecule of reactant. Okay, so from this this is the lecture 1. Next we can read next topic, sir, that is entropy gives free energy and the entropy changes for reversible and irreversible process and gives Helmholtz equation. Okay.